Hello friends, welcome to our channel. In this lecture, I would like to explain another example based on the frame. So already in the last lecture, I explained the things based on the continuous beams by using Staadpro connection. Here again I will explain the frame based on the Staadpro connection. So I will take some default name like frame 1 like that. Then again choose analytical mode. By default the units will be metric, that will be kilonewton, and again here create, click the option create. After selecting this option, you will get the user interface like this. Already I explained in the last lecture itself all these things and what are the properties. And again you can select the grids in the geometry and again beam grid. So in the last lecture I explained the properties, so therefore you can watch that video. I explained some basic tools and properties related to this grid. Here just I am choosing the node cursor at the 0th part, and again I am escaping from the present tool. Okay, so click escape option. Okay, so I am escaping from that present command and I am unhighlighting this default grid. See here, beam grid. So then there will be only one node. So yesterday I draw the beam based on the grid pattern, node to node connection like that. But here just I choose one node cursor. From this I will show how to draw the frame. Okay, copying the node and pasting the node in x direction like that I will show here. First select the node cursor here in the select option, select node cursor, and again I am selecting this node cursor, and again I am copying the node cursor. How you can copy? Control C. So I am pressing Control C here, and again paste, Control V. So whenever we are pressing Control V here, so the default dialog box will be appear like this. So see the following x, y, z values. X direction it will be some 0 meters, y direction it will be some 0 meters, z direction it will be some 0 meters. So I am drawing a frame of some 4 meters height. Okay, if I want 4 meters height means I will choose the column of some 4 meters height. Then again I will click OK. If you see here, there will be one more cursor, one more node which is at a distance of 4 meters in the y direction to the previous node, and again I will select those two nodes. Okay, and again I will copying the two nodes, Control C, and I will paste the two nodes, Control V, and again there will be x and z direction. So in the 2D only x and y plane. So just in the x plane, so I will be drawing a frame of some 6 meters distance. Okay, 6, just I am keeping 6 meters and then pasting. If you observe, the frame will be in the isometric view. So just I will select the view of front view in the view option. If you see, there will be 4 nodes which is at a distance of 4 meters and which is at a distance of 6 meters, and again I will select add beam option. So where add beam option? In the geometry, again I will select add beam. Okay, so then you will get one cursor here. Then I will add node to node connection. Again here node to node connection. Again here node to node connection. So here if you see here, I will draw the frame based on the node to node connection, node to node joins through the add beam option. In the previous class, I will add the beam. In the previous lecture, I will add the beam based on the grid pattern, beam to beam connection. Okay, see here, this is another procedure. You can remember all the basic points. Okay, then what is our next step? There will be translation. I'll repeat each and everything. I will explain the further classes also. So just to go for the design as is. Okay, next step is go for the loading option. Sorry, supports. Don't go loading. First step is to provide supports to the frame. Then I will choose one create option here. I will choose one fixed support, add, close, and again I will create one pinned support, add. So here after choosing this supports, so support, select support, and then if you choose use cursor to assign, you will get here like this. the symbol to the cursor like this. You can attach any particular end of that node. Okay, and again I am coming pressing escaping mode for getting out of this particular command, and again I will choose support 3, which is pinned 1, and again I will select in the select option node cursor, and I will select that particular node, and here you will get the option of assign to view, assign to selected nodes. You can choose assign to selected means automatically it will be assigned. So your supports will be created here. Then next point is properties. You can assign the properties. Here in the last lecture we choose only rectangular beam. Here we will choose some different. Again in the properties you can go define tab. Okay, then again here rectangle, I will choose rectangle of some 4.5 meters, and here some 0.3 meters y direction and z direction. Add, close, and again I will choose the properties one more. For the columns I will choose circular this time. So if you choose circular, just you will get only dia in the y direction. I will choose again default some 4 5 only. Okay, if I will take beam will be higher and column will be lower property, means it is not good. So I will choose the beam property only for 4.5. Again I will add here, and again circular column I will add only for the columns. For that I will select only columns, and then I will assign to the selected beams. Okay, and again rectangular one I will select this property, and I will use this assign to cursor option. So by that you will get different how to use different properties. So here I will assign, see here R2, R1 and R2. So again you can view in 3D mode whether it will be assigned or not. If you see the columns will be in circular mode and the beams will be in rectangular mode, like y direction and z direction, it will be in the rectangular mode and it will be in the circular mode. Okay, then our next step is prefer loadings here. Okay, then load case details, add one. Here choose dead load first time and give the name dead load, or you can keep default load case one like that only. Add, close, and next one again load case details, add. Again choose here live load LL or live load, add, close. Here again choose the dead load option and again add here. So what you are choosing for dead load, always self weight of the structure. Just by default -1. -1 indicates the load due to downward direction. We know the condition, which is factor of safety 1 B into D into its unit weight. For the beams or columns or entire structure it will be same, and just I am adding 1, close. And again for the live load you can choose some different loads here this time. For example I am coming from member load. Okay, here I am applying some -45 UDL on a particular beam, global y direction. I will add that one, close, and again I will choose another load of add. This time I will apply concentrated force in some 35 kilonewton. I don't know whether I am applying towards right or towards left. Just I will take here, later I will apply. One will be from right direction, another will be from left direction. Okay, add, close, and again here I am choosing live load, add, and again member load concentrated force like some 35 kilonewton only, add, close. Here self weight of the load will be adding to entire frame, that is assigned to view. Okay, assigned to the selected frame. Then live load, what about live load? So I will choose live load for the beam, therefore I am selecting the live load and then selecting the beam option, then selected to the assigned loads. So if you see here if you are not visible any loading, means just to go for view loading diagram, so automatically your load will be appears like this. So the label will be here. Then concentrated force of 35 kilonewton meter, I will select this one and I will select a particular column. I will apply from right side. So and I will apply to that selected beams. If you see here, the force will be applied in downward direction. Therefore here you can go to the edit option. you can apply the load in x direction. Okay, then see how the change will be. It will be towards left. So here before itself you can choose whether you can if you want to apply in x direction or y direction. Otherwise you can edit that one and you can apply like this. And again this one I will apply here. Okay, again assign to the selected loads. So see here again the load will be applied in x direction, y direction. I will edit that one and I will apply in x direction. See how it will be. If you observe, the load will be towards left. Generally the load one will be left and one will be right. So how you will get that will be right, towards right? So here I will take minus 35 and I will change here, means automatically it will be appear towards right. Before we don't know, if I apply towards negative means it will get towards right. If I apply positive value means it will get towards left. Therefore by default I will take some trial values, later I am changing the values. Okay, this is also one procedure how to edit the load values. Okay, then after selecting the loads like this, you just, the next step is you can analyze the commands. After loading condition is over, you just go for analyze the commands. Analyze, define commands, and by default add all the things and close, and again prefer run analysis. So you see whether your structure will be having some errors or there will be no errors. So there will be no errors and no warnings. Okay, then go for the design. Again before going to the design, you can select the design option and again choose by default concrete. Actually by default it will be steel, so you can steel design here. So therefore I am choosing concrete. So here you will get concrete design, and again by default it will be American concrete, so convert into Indian concrete and again select the parameters whatever you want, and again choose the same default values like FC, characteristic compressive strength of the concrete, and yield strength of the main reinforcement, yield strength of the secondary reinforcement. I am not choosing any bars because CAD will assign the bars by its own. After selecting the parameters, I will define the parameters. So the characteristic compressive strength of the concrete, last time I taken 25, today now I will taking some 20 only, 20 into 1000, which is generally the value in Newton per meter square. So here the value is in kilonewton per meter square. Therefore I am taking into 1000, add, and again FI main I will choose default 415 will be there, HYSD 500 also there, so I will choose 500 bars, 500 yield. Again I am adding here HYSD here, secondary yield also I will take the same stirrup bars, 500 into 1000. I will add this one and close. After defining this one and again go for commands. Here last time we selected only design beam option because there is only one continuous beam. So therefore here this frame is the combination of both beam and frame. Therefore I am adding the combination of beam and again I am adding the combination of column. If I designed slabs like multi-story buildings means automatically you will get slab option also, and then take off. So each and every time take off must be taken. Again next FC, characteristic compressive strength of the concrete will be applied to the entire frame. Therefore I will choosing assign to view option. If you see it will be highlighted, means the entire part will be taken, and FI will be applied, characteristic main reinforcement will be taken for entire frame. Therefore I am taking the option of assign to view, and similarly FI secondary reinforcement will also be taken to the entire structure. Then coming to the design part, so design beam I will choose only for the beam. So therefore I am selecting design beam and again assign to selected beams, design. For columns, just first I am highlighting the columns and then I will choose design column option. I will select the columns and assign to selected beams or columns. So I am selecting to that particular selected parts. So it will be highlighted. So your design will also completed. So this is the simple way how to design the beam or frame or anything. Then next step is to analyze the beam. Then define the commands, select all, add, close. Then here you can go for run analysis, save the structure. You see whether you will get any errors, you can rectify that errors. So there will be no errors, there is no issue at all. Then go for done. So after obtaining this one, again check in the post processing mode. Again what are the range you want, I will apply all the ranges. If you see whether the force in y direction or, so I will see the force in y direction. Again I will close this one. If you want, you can study the values from here itself. So I will choose here. And again, if I want the values, I will annotate here and I will check beam results, share of maximum values only. If you want end, you can select end values also. Annotate. If you see here, you will get maximum moments for the shear force and end moments also. End moments, maximum moments. What are the maximum moments? And again, if you want, you can select moment also, either in x direction, y direction, or z direction. Okay, but if I am taking moment and moment in z direction and these two, it will be clumsy. First I will close shear force and then I will take only moment here. So this is the deflected shape of the beam. So you will get bending moment diagram like this. So if you are confusing with these values, you can annotate this one in the beam results, take only maximum values for the bending, then annotate here. So you will get only maximum bending moment value on a particular beam. So at the ends it will be 0 here and you will get minimum value at the fixed support. Like that you can analyze the structure. If you want, you can see bending in x direction. This is the 2D plane, you won't get bending in z direction, you only get bending in z direction. So shear force in y direction. Then after that, next step is again go to the analytical modeling mode, check the design. For example, see here, I will click that beam two times, then I will check the concrete design. So here you will get the detailing of the concrete. So 12 dia bar, 6 in number in the top reinforcement, bottom reinforcement 12 dia bar, 6 members. So the spacing will be 8 dia bar, 10 mm, 300 mm center to center. Here if you see, Fi will be given 500, which is HDSD bar, HYSD bar. So FC will be M20 grade concrete. The depth of the beam will be 44. This is 0.29. So we know it will be taken as the effective length, center to center, like that also. Sometimes it will take. And I will close here and I will check any one column. Concrete design I am choosing. Here if you see, we know that minimum number of bars taken for the column. Circular column will be 6, square will be 4, rectangular will be 4. You see the numbers will be more than 6 only and the default diameter will be 0.45 what I chosen. And again you can read the data whatever you want here. So this is the detailing of the column, particular column. And again if you want, you can check the output result also. Again I will analyze the beam, so I will see the output how it will be. So see the output file. So see here, output file will be here. So here I will go for column design. You can see whatever the things you want. Beam design results, design column, column results. So steel area will be 1282. So sometimes by taking this steel area, so based on the steel area you can calculate area of this number of the bars by your own. In the general RCC design, mu will be equal to 0.87 Fi area of the steel d minus 0.42 xu maximum. So or else you can take the formula from the code. There you will get moment value and area of the steel values. So based like that also, here also getting area of the steel directly. By taking this area, you can calculate a number of bars by your own. Manually you can calculate like that also. That is very efficient actually. So taking the area of the steel from the Staad, because designing of the Staad is very easy. But obtaining whatever the area of the steel from the Staad, take down that Staad values and then calculate steel bars by your own. That is also good for the practical considerations. See here, each and everything will be coming in the output file. For example, 8 bars we are using 339 weight, which we are applying for shear reinforcement, and 12 bars are applying for top and bottom reinforcement. So this is only singly reinforced section, means you will go to only bottom reinforcement. We are providing hanger reinforcement in the top side, we know that condition. Okay, so this is the design and analysis of the frame. Thank you so much for watching this video. If you really like this video, please like this video
share it to your friends and subscribe our channel. Thank you so much.